Together, sections 14.1 and 14.2 will focus on imaginary numbers. Take the square root of a negative number. All you have to do is take out the imaginary piece. So we have j times the square root of 16, and then take the square root of whatever's left. So the square root of negative 16 is 4j. Powers of j. Remember that j to the first power is the square root of negative 1. These actually will work in a pattern. J to the second power is the square root of negative 1 squared. And squaring and square rooting undo each other, so that's just negative 1. J to the third power, so the square root of negative 1 to the third power is the square root of negative 1 times the square root of negative 1 times the square root of negative 1. This piece is the same as j squared, which is negative 1. And then this piece, the square root of negative 1 is just j. So negative 1j or just negative j. And then j to the fourth power is the square root of negative 1 to the fourth power. So that's the square root of negative 1 times the square root of negative 1 times the square root of negative 1 times the square root of negative 1. And you'll notice that we have j squared twice. So negative 1 times negative 1 is positive 1. Now here's where they start repeating. J to the fifth power is j to the fourth power times j. Well, j to the fourth power is 1, and j is just j. J to the sixth power can be written as j squared times j squared times j squared, which is negative 1 times negative 1 times negative 1, which is negative 1. Notice it's the same thing as j squared. So then by now you've probably started to guess that means that j to the seventh power is going to be j. So after every 4, they repeat. So what we want to do when we are, since the powers of j repeat every 4 times, we're going to take 4 and divide it into the exponent. 4 goes into 23 5 times, and 4 times 5 is 20. That will give us a remainder of 3. It's the remainder that we really want to focus on here. A remainder of 3 means that j to the 23rd will simplify to the same thing that j to the third will simplify to, which is negative j. And then j to the 52nd power, we divide 4 into 52. We get a remainder of 0. So j to the 52nd power with a remainder of 0 will simplify to the same thing as j to the fourth power, which is 1. J to the 30th, if we divide 4 into 30, we get a remainder of 2. So j to the 30th will simplify to the same thing as j squared, which is negative 1. And then j to the 37th power, if we divide 4 into 37, we get a remainder of 1, which means j to the 37th power simplifies to the same thing as j to the first power, which is just j. Now, when we multiply radicals, you do want to take out the imaginary piece first. So this is j times the square root of 3 times j times the square root of 27, j squared times the square root of 81. J squared is -1, and the square root of 81 is 9. And so that simplifies to -9. And for the second one, 3j times the square root of 7 times the square root of 28. So 3j times the square root of 7 times 28, which is 196. And the square root of 196 is 14. So 3j times 14. And then 14 times 3 is 42. So we end up with 42j. To simplify expressions, here if we have a division problem, I'm just going to separate this 8 over 4 minus 24j over 4. And then I can divide 8 divided by 4 is 2, and 24 divided by 4 is 6, so that's 6j, minus 6j. Distribute, we're just going to multiply. 2 times 6 is 12j, 2j times 6 is 12j, minus 2 times 3 is 6, j times j is j squared, and then again simplify. 12j minus 6 times -1, so 12j plus 6. A conjugate is the same thing with a different sign. So 5 minus 2j and 5 plus 2j are what we call complex conjugates. We can also solve these using the quadratic formula. I want to get it set equal to 0. X squared minus 2x plus 2 equals 0. And then use my quadratic formula. X equals -b plus or minus the square root of b squared minus 4 times a times c all over 2a. So the opposite of b, since b is -2, will be +2 plus or minus the square root of -2 squared minus 4 times 1 times 2 all over 2 times a, which is 2 times 1. X equals 2 plus or minus the square root of 4 minus 8 all over 2. X equals 2 plus or minus the square root of -4 all over 2. And then take out the imaginary part. 2 plus or minus j times the square root of 4 over 2. X equals 2 plus or minus 2j over 2. And then since 2 will go into both of those, we end up with 1 plus or minus j as our two possible solutions. We can also add and subtract. We just need to combine like terms. 3 plus 6 is 9. 2j minus j is 1j, so 9 plus j. 6 minus 3 is 3. And then here we're actually going to need to do a little bit of simplifying. So this is plus 4j minus, since I'm subtracting, 3j. So 3 plus j is what we end up with here. And then multiplying and dividing. Here we want to FOIL. 2 times 3 is 6. 2 times 5j is minus 10j. 3 times j is plus 3j. And j times negative 5j is negative 5j squared. Now simplify. That's 6 minus, I'm going to combine my like terms here, 7j minus 5 times negative 1, because j squared is negative 1. 6 minus 7j plus 5. Combine my last little bit of like terms, 11 minus 7j. And then lastly, I'm going to need to multiply by the conjugate here on the top and bottom. So the conjugate of the denominator is 3 plus 6j. I'll multiply by that on the top and the bottom. And in both cases, I'll have to FOIL. In the numerator, that's 12 plus 24j plus 15j plus 30j squared. In the denominator, 9 plus 18j minus 18j minus 36j squared. And now let's simplify a little bit. 12 plus 39j plus 30 times negative 1. And then on the bottom, notice my middle terms are going to cancel out, and I have 9 minus 36 times negative 1. 12 plus 39j minus 30. 9 plus 36 on the bottom. 12 minus 30 is negative 18, so negative 18 plus 39j, and 9 plus 36 is 45. And you can leave it like that. If you see something that will simplify, you can simplify it, but if you leave it like that, I'm fine with that as well.